Today we are beginning the final unit of the course, or for Applied 30S, and it is quadratic functions. There are 3 lessons in this unit. Lesson 1, we will look at characteristics of quadratic functions. Then lesson 2, applications of quadratic functions. And finally, systems of equations. You will still need your graphing calculator or Desmos. And also you'll need your reference sheet as we go along through this unit. Remember, your 2 reference sheets are the first one on calculating instruction for applied math. And the other one if you're using Desmos, how to display data and find the line of best fit. So your booklet, in the inside cover, you probably would like to scan through the outcomes that will be covered in this unit. So you can do a checklist to see which one of these outcomes you can demonstrate. Okay, so how to scan that, and that will give you an overview. If you can do any of these, it means that your learning curve wouldn't be that steep. Otherwise, will be probably relatively new to most of you. So lesson 1, characteristics of quadratic functions. I've broken up lesson 1 into 2 parts. But in this lesson, we'll be looking at quadratic functions. And quadratic functions are generally one with a curve. If you throw a football or a baseball or any kind of ball to someone who's far away, it will have this kind of a trajectory called a quadratic. Goes up. Here's an example. And you can see example in bridges or even contact lenses that you wear. So that's quadratic function, basically. So we look at the quadratic function, we look at its shape, its vertex, what does it mean? Leading coefficient and behavior, y-intercept, x-intercept, and range. In the previous unit, we looked at linear functions. We didn't look at vertex because there's no such thing as vertex in a linear function. So there's one of the many differences between quadratic functions and linear functions. For those of you who've seen satellite dishes, it is a quadratic function. It's a parabolic shape. Now, a quadratic function, right? It's so different from a linear function, but it's a function that has the form y equals ax squared plus bx plus c. Now, when you look back at your linear function, it was like y equals mx plus b. Now, that's your linear function. Or sometimes you'll see it like this, f of x. But generally, what we have looked at in the past, we looked at y is equal to. Now, a quadratic function, on the other hand, has the form, so we can say a quadratic which has the form y is equal to ax squared plus bx plus c, where a is not equal to 0 and b and c are numbers. It's a very simplistic information, but we'll go into more details later on. So this is a quadratic function. So let's look at some examples, right? And we can use our graphing calculator to determine which of the following are quadratic functions. So I'm going to demonstrate using the graphing calculator. But you can also use Desmos. We'll have the same feature as Desmos. But let's look at the graphing calculator. Here we have y is equal to 0.02x. Remember, quadratic functions have this shape. So curve is not a straight line. Okay. So anything that has a shape that looks like, now it might be going up, or it might be going down. So these, what a quadratic would look like. If you look on a coordinate plane, it will have these shapes. So let's look at a calculator and see which one of these will fit into it. So I'll go to my y equal button first, and generally I want to clear. Now I want to, and by the way, you should know by now to reset. I'm going to reset my calculator. So memory, I'm going to go down to 7, and I'm going to reset it all. Okay, so I clear all other previous data I put into the calculator. Now, let's look at the first one. So y is equal to, go to my y equal button, and 0.02x. Now your square button is right here, to the power 2. That's the easiest one. There's a shortcut. There are other ways you can do it. You can press your exponent button and 2. Now subtract 3. So graph that. Notice that one, it is going up, but you probably can't see it so well. So you may have to adjust your window. And I may want to make this would be negative maybe 100. And maybe this positive 100. There you can see. So this is a quadratic because it has that shape. See. Okay, so we can say this is a quadratic. The next one, let's see what it looks like. I'm going to go back to my graph here, and I'll clear that. Now I'm going to go back to my window, and I'll go to standard again, because I did change my window. Go back to the standard. Remember, your standard window has a domain from -10 to +10, and the range is from -10 to +10. So let's try that now. 2. Now, oops, I have to go to my y equal button. And this is where you will have to use your exponent button. Let's show you what I mean by that. Now we have 2x, oops, not a bit 2 here, 2x. Now to the power 3. To get to the power 3, I need to press this button here. That's your exponent button. And then to the power 3. Notice, that's me the exponent to the power 3. Then +1. Now I need to move over. Now, if I would press plus here, it's up there. I don't want it up there. I want to go, I don't want to add any exponent more. So I'm going to delete that. Now to get to the normal, you press your right arrow key here. So remember that? You press this right arrow key to get down. Plus. Now the reason I do that, I'll go do this again. I press 2x to the power 3. If I do not press the right arrow key, I'll press this here, and I put 1 now. It's taking all my exponent to 4, and I don't want that. I want this +4, +1 as my c in this case, my constant. So I'm going to go back, delete. There's my right arrow, and I'll change it to what I wanted, +1. Graph. No, this is what I call a cubic function. And you learn about this in grade 12. So this is the cubic function. When it's a power 3, it means that's a cubic. Notice power 2 means quadratic. So this is, but you can tell by the exponent. If its exponent is 3, then it's not a quadratic. Now the next one is very difficult to tell because here you have two binomials that multiply. If you were to multiply this, let's see, we'll have something different, right? So, but let's use our calculator. So I'm not going to go off. So good, negative here. Put your negative sign. Do not put your subtract sign. Open bracket. X plus 3, close bracket, open bracket. X minus subtract 1, close bracket, and graph. Notice now this one is going down, and it's a quadratic. So this is a quadratic. So you're using a calculator at this stage. As we go further into this lesson, I'll be showing you how to do this algebraically. Now the next one is very much alike a linear function, but let's look to our calculator to verify that. So go back to 2x minus 1. And there it is. So that's a linear function. So we're going to say, no, this is a linear function. Okay. The next one, E. So let's go to my y equal button, clear my calculator, -2, open bracket. Oh, I need an x over there. X, -2x, open bracket, x squared plus 1. Now, you may jump to the conclusion that this is a quadratic, but you have a -2x outside of the bracket. If you were to do this algebraically, this becomes -2x to the power 3. So what do I mean by that? Say I have -2x times x squared. Then we have -2x plus x, so that would give us -2x. Now this would be -2x would be -2x to the power 3. Because when you're multiplying variables with that are the same base here, you add the exponents. And this would be 2x. So this is a cubic function, it's not a quadratic. So let's see what it looks like. Okay, so now this tells me this graph is not going up or not going down continuously. It's what they call a decreasing function. It starts from the left, quadrant 2, and it goes to infinity. So -infinity, which is in quadrant 4, to positive infinity in quadrant 2. So this is a cubic function. Now the last one, let's see what. And this one here, the same thing would apply here. We have x times x would be x squared, x times -5 is -5. So y is equal to x squared minus 5. But let's, so we should put a colon here, but they're not equal to. So this would be, let's try to clear our calculator here. We have x, open bracket, x minus 5, close bracket. And there it is, it's a quadratic. So quadratic function has this form, ax squared plus bx plus c. Now, sometimes you may not have the b, sometimes you may not even have the c, but as long as you have a, negative or positive. Now, if a is negative, the graph is going down. So this one here. So this is like y is equal to negative ax squared. And this is y is equal to positive ax squared plus bx plus c plus bx plus c. Now this could be a negative. So that's the form quadratic functions take. So as we go further into the lesson, we are looking at the vertex. And the vertex is the point where the graph changes direction. If it's going up, it's a minimum point here on the y value here. So the vertex is a point where the graph changes direction. In this case, the vertex, the y value here becomes a maximum. Here, the y value is a minimum. We'll talk also about the leading coefficient and behavior, y-intercept and x-intercept, and the range. So here we have an equation, right? Ask you to sketch a graph of y equals x squared plus 2.25x minus 7.88. Label the y-intercept and the x-intercept. Now this is very real. Probably you will need your instruction sheet to find the x-intercept and to find your y-intercept. So we'll go through these examples. So here we have x-axis, y-axis. Now you can label these. One, indicate your scale. -1. So make this a little bit. Now, we'll use your calculator. And you're going to, let me clear that. You enter into your calculator exactly what's given to you. And yes, you're asked to find the x and y intercept. So first of all, we enter this into our calculator. We'll do a sketch. And then we'll find the y-intercept and the x-intercept. So let's go straight to it, and let's put that y is equal to x squared. Remember your x button is here, and this is a shortcut for your square button. Also, on the other hand, you could have used this one here and press 2. Gives you the same thing. So let's go to shortcut for now, x squared. I notice it's jumped down already for you, so you don't have to move the right arrow key when you use the shortcut. Plus 2.25x minus 7.88 graph. So notice your graph, and I'll center it here, and so you can do a sketch. Right now, it seems to be going through, the x-intercept seems to be 2 here and -4. And the y-intercept, it's around 1, 2 at this point here. So we do a sketch around this point. So we have 2, -4, and we have 1, 2, 3, 4, 5, 6, 7, 8. Close to 8. But so we have -3, -4, we have 3, 4, we have -3, -4. So we know it goes through just over 4, between 4 and 5. We're not sure. So it seems to go. It's in between. From my graph here, it's between 4 and 5, but closer to 4. Okay, so put a point here. Tell me my graph is going there. It's between 7 and 8. So it seems to be closer to, let's see, we'll put that on here, and it goes through room 2. So this is a sketch, right? We'll not precise yet. So we'll have a graph going up. Now we need to find exact values here, x and y intercepts. Notice I put my arrowhead, meaning this graph is going up continuously. Now I need to find my x and y intercepts. So I'll zoom back out so you can see the full keypad. Now this is where you will need to use your x-intercept. Now to find your x-intercept, I'm going to use your instruction sheet, or by now you may have memorized it, which is something you probably want to do. It makes life easier for you. So let's find our x-intercept. Now there are 2 x-intercepts here. So our instructions are, 1, you have your y equal button. Next, we want to enter y equals 0 in line 2. 0. I just got a graph and to make sure my y equals 0 is indicated. Next, second trace for Cal and choose 5 intersect. So second trace, and I'm going to go number 5. Notice there are 2 intercepts here, so we'll have to do each one separately. So I'll go up here to first curve, close to this one I would like. Press enter, press enter, press enter again. And the intercept there is 1.899 or 1.9. So it's not 2, although it looks like that. It is 1.89. So this point here, so our x is equal to 1.89. Now we need to find the other one. And we'll repeat the steps, just tick. So we go back, second trace, intersect. But this time, I'm going to go to my left by using my left arrow. And make sure it's very close to the point of intersection. And press enter 3 times. And now you're given is -4.14. We can say that's 4.1. So -4.1. Now we need to find our y-intercept. So those are our x-intercept. And you will use the instructions here on how to find your y-intercept. So now this is our y-intercept. It's only 1. So we have an equation in y equal 1. So now we're going to go to second trace value and let x be 0 and y is 7.88, or negative 7.88. So y here is negative 7.88. So there's our sketch, our x-intercepts and y-intercepts. Here's the second one. Notice, just to highlight here, positive x squared. And the graph is going up. So if we have y is equal to ax squared plus bx plus c, tells me this graph is upwards. Now, you suspect now negative, the graph should be going down. Let's do a sketch of that now. I'm going to go back to my y equal button, clear my graph, and I'm going to enter negative. Don't use a subtract sign here, negative 2.65 x squared plus 3.9 x plus 12 in our graph. Now notice I'm missing part of my graph at the top here. So I need to adjust my window because my window is from negative 10 to positive 10. So this graph goes higher than positive 10. So I need to go to my window now, and where y maximum, I'll change that to maybe 15. Let's see what happens here. Now I can see what I would call the vertex of the graph. Now, you could estimate the x-intercepts here and the y-intercept. Well, let's zoom in here. I'll show you what I mean. If you look at this, it's approximately close to 3, and it's between -1 and -2. And the y-intercept, now you could guess what it is, but from your equation, it's 12. So we'll go ahead and first of all, indicate our scale. We have 1, -1, -2, -3. So -3 here. We have -1, -2, -3. We have 1, 2, 3. We have 1, 2, 3. So the -1, -1, 1. This goes up, we know, to 12. 1, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this graph goes up higher. So let's sketch it right now. We're going to do a sketch. So here is 12. The graph is going through there, and it's going between 1 and 2, and between 2 and 3, close to it. And it's going down. So I need to find these intercepts. Notice I am using the arrowhead here. It indicates that the graph has no restriction. It's going down to -infinity. It's in quadrant 4 and quadrant 3. So let's find the y-intercepts, or intercepts first, or x-intercepts. So back out. And this will go back to your instruction sheet. Well, you can look at that, but I'm going to go through it now. Now I need to find my x-intercept, so second trace. Now, go back to my y equal button. I didn't change my y2 button. I leave it, so my y2 line equation, because I know I'll be finding my x-intercepts. So I need y equal, in line y2, y equals 0. Back to graph, so I go second trace, go down to intersect. Now I want to find the one that left this time, so I'll go down and slightly below the x-axis here. You don't want to go too far below it, although that shouldn't matter. So now I have it here, I press enter, enter, and enter again. So the x-intercept on the left side, it's negative 1.5. So we can make this here negative 1.5. Make it 2 decimal places would be 5.2. Now we need to find the other intercept. So we'll go second trace, intersect again. This time I have to press my right arrow and go to the other side. So below, press enter 3 times, and there's 2.98 or 2.99. Okay, so this is 2.99. So that's your intercept. Now you need to find your y-intercept, which is second trace value. Let x be 0, then y is equal to 12. Notice, if the equation is written in its form y equal to ax squared plus bx plus c, your c is the y-intercept. You can tell, negative 7.88. Go back here. So negative 7.88. And here is 12. So the y-intercept is 12. Y-intercept is negative 7.88. Now, for those, just to emphasize the domain and range. Now, look at this graph here. It is going to my left forever and to my right forever. So that will give me my domain, which is from negative infinity to positive infinity. So the domain, now you have to write a bracket of this form here, negative infinity to positive infinity. Do not use a square bracket. The square bracket indicates that it touches that point. Infinity is a concept. It means that you don't know where it ends. It's somewhere out there. So we say it doesn't touch it. The range, on the other hand, we need to find the minimum point here. And that's we will do in the next lesson, to find the minimum point. So the domain will stick for now. So the domain for here now is from negative infinity to positive infinity. So what we've done so far, we sketched a quadratic function using our calculator, and then find the x-intercepts and the y-intercept. And I've indicated a domain. Now, the next part now we're going to look at is the vertex. We call it characteristic. Now, and the vertex will help us to find the range. Now, the vertex of a parabola is a point where the direction of the graph turns, something called the turning point. So, point where this graph turns is the vertex. If the graph is an increasing function like this one here, we say it's the vertex, well, here would be the minimum point. And if it's going down, it's the maximum. So if you draw a vertical line, now if you were to draw a vertical line right through the vertex, you will see it's symmetrical. In other words, the right side here is exactly as the left side. If you draw a line right through here, it's called the axis of symmetry. You draw a line right through with the vertex called the axis of symmetry. Symmetrical means like what it's alike. On the right side, exactly as the left side. It's not the middle. So this is your axis of symmetry. We'll learn more about this later on. So the vertex is a very important point because it tells us the maximum point or the minimum point. So here would be the minimum point. The graph doesn't go lower than that. Let me remove this axis of symmetry here. So this graph, the minimum point is at the vertex. If the graph is going down, yes, now the maximum point is the vertex in this case. So here is your maximum point, which is your vertex also. So from the vertex, we can find the maximum or minimum value. Okay. So let's look at some graphical representation. So here. So we can see the domain of a quadratic function is limitless, right? In other words, it goes to the right forever and to the left forever, or negative infinity to positive infinity. Same as this graph here, it's from negative infinity. So the domain, so we can write the domain here as x as all of the real numbers. In the previous unit, I said you can write a domain in two forms. You can write it as in what we call the interval notation, and that's the one that goes from negative infinity to positive infinity, or this is called the interval notation. Or you can write it, what we call in the set notation. You can say x such that x is a set of real numbers. In other words, there's no limit. Any number you can think of, there's an x value that will fit this graph. Same as the other one here, or these other ones. So interval notation, this we call set notation. The vertex now, and this is why the vertex is important. The vertex has this point here, the minimum, this point that is here, it is negative 2, 0. So here we have it here. This point here is negative 2, 0. So this is your x, that's your y. So negative 2 is your x value, which is negative 2 here, and y is 0. So the lowest point on the y-axis here is the y value here, which is 0. So the range, now this graph is going up. The range is from 0 to infinity. Now you need a square bracket. It means it touches 0. So the vertex is negative 2, 0. It means that the graph touches the point 0. So the range is from 0 to infinity. So it's going up. Here, a vertex is 4, negative 6. So this point here. See, your lowest point here is negative 6. And this is 4. So this is your vertex. Your domain is still all the real numbers, or from negative infinity to infinity. Your range, on the other hand, is your y values. So the lowest point here, this graph doesn't go below where y is -6. So we say the range is from -6 to infinity, including -6. Notice curved smooth bracket means that it does not touch, it doesn't reach infinity. The square bracket here means it touches it. So be careful with the domain and range. So we need to know the vertex. Here, the vertex here is x is 0 and y is 10. So this is your maximum point here. These 2 points are your minimum. So now your range is from negative infinity to 10. Notice you always start from negative to positive when you're writing range or domain. Okay. So we know our domain is from negative infinity to positive infinity. Now your range, on the other hand, now is from negative infinity, which is way down here, going up to positive infinity. Okay. So here's a negative infinity. Going up here is positive infinity. But it stops here at 10. So my point here now is 10. So this is going from negative infinity to 10. So this is my range. Here, my range is, the range is from 0 to infinity. Here's -6 to infinity. Now, it's from negative infinity to 10. And it includes 10. The vertex is 2, 5. So this is my maximum point. You can hear it's a maximum point. So our domain is still all the real numbers, because as long as you get these arrowheads, it's pointing, it's going to infinity, which is negative this way. So it's going from negative infinity to positive infinity, or all the real numbers. Okay. This is what we call the set notation. The range, on the other hand, is from negative infinity going up to 5. So negative infinity to 5. Okay. So let's use our knowledge of what we did here to calculate. So we don't need a calculator for now. We're just looking at the graphical representation. Say the vertex, the range, the following function. The vertex is the point where the graph changes direction, or a turning point. So here's a turning point, or the minimum point. So at this point here, a graph is 5, 1. So the vertex is 5, 1. Your domain is from negative infinity to positive infinity, or we can say x set of real numbers. We'll write that as from negative infinity to infinity, or x, so x is a set of real numbers. Our range now is from 1 to infinity. Our axis symmetry is 5, so but they didn't ask us for that. So our range is from 5, including 5, okay, to infinity. Next one here, we have our maximum point. Now this graph is going down. So our vertex is 5, 4. X is 5, Y is 4. Domain would be X. So X is a set of real numbers, or negative infinity to infinity. Now your range now is different because your maximum point now is 4. Your minimum is infinity. So we say it's from negative infinity to 5, including 5. Okay. So you need to find your vertex. So this is your vertex here. Or, in this case, maximum point. This is your minimum point. That's why you can say the graph is from 5 to infinity is going up. Here, the graph is going down, which comes from negative infinity to 5. And the convention is that you always start from bottom going up for range. For domain, is from your left to right. Now let's look at some characteristics of a quadratic function. This graph is called a parabola. The shape of it is called a parabola, opening upwards. So as long as the two arrowheads pointing upwards, we said the graph is opening upwards. The sign of a leading coefficient would be positive. This would be y is equal to ax squared plus bx plus c is the form. So the a, the sign in front of the ax squared, sorry, the sign in front of the ax squared is positive in this case. The end behavior is from quadrant 2 to quadrant 1. We said, why do you see from quadrant 2 to quadrant 1? It's because the graph is always read on in what direction you're going on the x-axis. You're going from negative to positive. So we say we move from negative x to positive x, 2 to 1. Or you look at the direction, the change of the y values as you increase in your x. As you increase in x, what happens to the y values? The y-intercept here is 0. That's where it crosses the y-axis here. The x-intercepts are negative 4 and 0. The vertex is this point here. And the vertex is negative 2 here. We have negative 2 here, and this is going to be 4. So negative 2 and negative 4. Maximum value, there's none because it's going to infinity, but there's a minimum value here. The minimum value here is negative 4. That's the lowest point here, which is negative 4. Maximum value none. The domain is from negative infinity to positive infinity, or all the real numbers. And the range now is from negative 4 to infinity. So that's the characteristics of a quadratic function. So we'll use this to answer the following questions. So this is in your booklet. So in this case, you don't need your because the graph is given. We're just looking at how to describe these functions. Now the first one, the direction, and you can use this as a guide. The parabola is up or down. So example 2. The shape, the direction is the parabola is going downwards. So you can put down here. So the parabola is parabola opening downwards. The sign of a leading coefficient. Now, if it's going down, it's negative. The first one we did here, the graph is going up, it's positive. Because it's going down, it's negative. Now, end behavior is what quadrant, we're looking at the quadrants here. So it's going from quadrant 3 to quadrant 4. Now this is quadrant 1, this is quadrant 2. So we said end behavior from quadrant 3 to quadrant 4. The x-intercept, the y-intercept first, is that point there, which is 6. Or we can say x is 0, y is 6. The x-intercept there, 2. The x-intercept could be -2 and 6. The vertex is the point where we change the direction, so we can put here the vertex. And at this point here, this is 2, and this is going to be 8. This point is 2, 8. So the vertex is 2, 8. Minimum value, there's none because this graph goes down forever. You can say infinity, but there's none. The maximum value is your x coordinate of your vertex. Sorry, your y coordinate of the vertex, not the x. Sorry, the y coordinate of the vertex is your maximum value. In this case, it would be 8. The domain is from -infinity to infinity. So we can say, or we can say x such that x is a set of real numbers, or -infinity to infinity. The range is from -infinity, because we're going up, to a maximum point, which is 8. Let me close our bracket. Now, if you would like to write this in interval notation, set notation, which is a little bit tricky, but you'll get to use hang of it. You can write this y value, that's correct, such that y is great or less than or equal to 8. Because it's less than, anything less than 8, the y value is valid. So less than or equal to 8, where y is a set of real numbers. Now, interval notation is a little bit simpler to write, so you can stick to the interval notation rather than the set notation. Now here we have one going up, and it's very similar to the first example we did. So you can use this as a model. So direction, we know it's going up. The parabola is going upward. The sign of a leading coefficient is positive. We know that because it's going up. The end behavior is from quadrant 2 to quadrant 1. So quadrant 2 to quadrant 1. The y-intercept is right there, which gives me, in this case, 8. Or we can say 0, 8. The x-intercept is only 1, which actually happens to be the vertex, 4. There's only 1. So only crosses the x-axis once here. The vertex now is 4 zeros. My vertex there. X is 4, y is 0. So 4 is 0. The minimum value is 0. Maximum value, none, because it goes up wherever. The domain would be x set of real numbers, or negative infinity to infinity. The range now is from 0 to infinity, and it touches 0. So that's looking at the characteristics of a quadratic function. So we looked at the parabola opening up, standard leading coefficient, end behavior, intercept, x-intercept, vertex, minimum value, maximum value, domain, and range. For your assignment, you want to try looking at assignment 1. Assignment 1, question 1. Also, for your hand-in assignment, now this is a practice assignment. For your hand-in assignment, you want to complete question 1 also of assignment 1 of quadratic function for your hand-in. So you use this model here, as you can see, it's almost identical, to find direction going up, sign of leading coefficient, end behavior, y-intercept, x-intercept, vertex, minimum value, maximum value, domain, and range. Our next lesson, we were looking at, you're only given an equation, and now you have to find the shape of the graph. That's our next lesson. Okay. So to recap, our lesson, quadratic function, begins with lesson 1. We look part 1. We look at the shape, the vertex, leading coefficient, end behavior, y-intercept, x-intercept, and range. For today's lesson, we looked at graphs that you're given the graph and you're asked to find the characteristics of that graph. Your assignment for today is assignment 1, practice assignment, question 1 on page 8. And for your hand-in assignment, assignment 1, question also number 1.